table.
Let's go back to sine, cosine.
It's the other one of those, the great triumvirate of sine, cosine, and tangent. We're going to talk about sine eventually in this class too. It involves a rabbit, squirrel, and a stream. But we'll get to that. Like a lot of stuff does, rabbit, squirrel, and a stream. It involves a lot more than that, but the rabbit, squirrel, and the stream is a cute way of introducing it. So the grade, this idea of grade that we have come up with today, this rise over the run, is exactly the same thing as you've already said as slope, right? We know it's slope. It's slope. Slope, totally. But it's also this third thing, which it is the tangent of the angle formed. So whatever angle that is formed by the road that has that grade, its tangent is equal to that grade. Now you don't have to worry about any kind of computation for this. No computation, put your minds at ease. No weird formula you plug x into and like, oh, I hope I did this right. The way you're going to find these angles is by looking them up on a table. It's that simple. You're going to look them up on a table. What table? You can Google it. We'll Google it right now. Yeah, we're going to Google it. Because there's no reason. There is a mathematical equation, or 20, for the tangent of an angle. I don't want to kill you with boredom by learning them. I want to show you a very efficient way of getting this angle, if you need the angle. Okay? So, can I pull the screen over this? I'm sorry, I'm writing this and then pulling the screen down. Is that all right?
Yes.
So in order to know... Week 10. I'm guessing week 13. In order to know... Whoops. Blank screen. Escape. Google. And FYI, I gave you kind of instructions and also one of these tables in that extra resources link. So that Math 105 extra practice, you click on that, you'll go down, that'll show you where all this is. I just go to Google and simply type in tangent table. Spell it correctly. Hit enter, and I default to the images, because that way I can pick the one that looks the best to me. Let's see, some of these are okay. Oh, this is a nice clear one. KACREK.com. Hopefully it's not loaded with viruses. There we go. Now, it just looks like a bunch of digits to you guys. Like, what the hell? Not very helpful. Not very helpful. But what you have to realize you're looking at, because the grade is the same thing as the tangent. Tell me what's on your mind. What are you thinking? What are you thinking right now?
I was just looking at the calculation on the board.
Oh, okay. I'm sorry. I'm excited. I saw this point going. I'm like, oh, I should let it just go. Go ahead. No. Go ahead.
I'm not sure.
That's okay. 45 is interesting, yes? Look at 45. Good. Let's go right to an interesting angle. 45 degrees. Tangent is equal to 1. Now, imagine a 45-degree angle for a moment. Just in your mind, imagine a 45-degree angle. Draw it with your hands. What do 45 degrees look like with your hands? Pretty damn steep, actually. Even the best skiers on Earth would have a bit of a hard time skiing this if it weren't perfect powder. But perfect powder, you'd be in a dream. 45 degrees. Now remember all that geometry we talked about earlier today? Right? That beautiful geometry about the 3 angles of a triangle equaling 100 degrees? Okay, so in this particular triangle, if that's 90, this one would be 45. The one that you're forming with your hands. What would the one up here be? It has to be 45 as well, to add up to 180. Does anybody remember what kind of triangle it's called when you got 2 angles that are the same? It's kind of a hilariously funny... Oh, that's 3 sides the same. And equilateral is a type of this. Oh, that's a great point. Next, tell me your name again.
Emily.
Wait, we got Emily?
No, Michelle. And Emily.
Emily and Michelle. Michelle, I see. Go ahead, Emily.
Isosceles.
Isosceles is exactly 2 sides equal. Or exactly 2 sides equal, that's what equilateral. So, this hypotenuse, or long side, is the different one. But these 2 angles being the same mean these 2 sides are the same. So make up a number for this one. 8. If that's 8, what's that? 8. Make up another number for this one. I hear 100. Is that what I heard over there? 100? If that's 100, what's that? Make up another number for this one. Did somebody say 72 earlier? Let's use it right now. 72. What's this? So if you take the rise and divide it by the run, what number are you always going to get?
1.
I'm giving you the answer right now. You're always going to get 1. Yeah! See, that's the noise I like to hear. Oh, yes. Makes sense. Good. Like that. So this, when it says tan for tangent, what it really is rise over run. The rise over the run, the grade is right there. Now, it's in decimal form. It's not in percentage form. So when it's 1, it's not 1%, it's 100%, a 100% grade. If you ever encounter a road sign where it says caution 100% grade ahead, get the hell out of there and go somewhere else. You will die. Nobody makes roads that are 100% grades except a few I've seen on crazy desert islands from pictures, and they're insane. They're impossible to maintain and impossible to drive down safely. So, when you see 1, it's 100%. You can have grades that are well over 100%. All that means is the rise is bigger than the run. And we will deal with these. In turn, we'll deal with it. You won't see them on roads, thank God. Cliffs are a good example of where a rise is bigger than a run. A cliff. You don't see roads usually on cliffs. You see rappelling on cliffs, right? But, so you come down here, under 45 degrees. 64, 94, right? That's 64.94%. That's almost 65% grade. Also very steep, very steep. Let's keep backing up. Let's keep backing up. What's this guy right here? 38, 38? 38% grade with some change. 38, a third percent grade. So what are we looking for? 6%. Go ahead, Amy.
So it's like 3 degrees?
It's, yeah, between 3 and 4 degrees. 3 degrees has a 5.25% grade. 4 degrees has almost a 7% grade. So just say it's somewhere between 3 and 4 degrees. Boom, you're done. If you need more precision, go to that extra resource page. I show you how to get calculator precision to as many decimal places as you need. That's all it is. You probably don't need that much precision in your lives. Because the 6% sine grade isn't exactly 6, it's close to 6. Precision is kind of relative in a sine like that. Go ahead, Amy.
Do you think that Americans relate better to percentage and that's why they don't tell us degrees? Because it seems like degrees make more sense to me. But...
Believe it or not, this ties right back to Matt's point from earlier. It's how whoever defined it in the first place. I don't know who defined grade on a road in the first place and decided to make it rise over run. I personally believe that some use of degree would make more sense. And we're going to attack this problem first thing on Monday. When you deal with pure slope or pure grade, you have to know what the run is. When you're in a car driving on a road, you usually don't. Because you're not driving on the run, you're driving on the... kind of. If you had to pick one of the sides of a triangle, what side are you driving on? The hypotenuse. Long side. Right? So it'd be nice to have something involved with the long side. Now, there's a mathematical reason why we can ignore that in most cases, which we'll deal with on Monday as well. There's a couple things I want to hit on Monday we didn't get to today. I want to deal with the hypotenuse or the long side and how it plays in. I want to deal with average grade. Thank you, Pam, for bringing that up earlier. That's a very, very good point. And I want to deal, actually, those are the 2 things. Average grade and deal with the hypotenuse. And that'll take us outside. So if you didn't bring something warm today, got off easy. We can bring something warm for next time. Come here first, though, next time. Come here Monday first, and then we'll shoot outside. We'll regroup. I got some more grades I want you guys to look at on the PowerPoint. Then we'll head outside, then we'll head back in. We'll have grade under our belts, so to speak. Cool? Have an awesome weekend. Thanks for dealing with the chaos this morning.